Linear programming in Excel. Practice example. Let's talk about an advertising mix. Ooh, big question here. I love it. Advertising director at a large retail store in Columbus, Ohio is considering 3 advertising media possibilities. 1, ads in the Sunday Columbus Dispatch newspaper. 2, ads in the local trade magazine. And 3, ads on Columbus's WCC TV station. Okay, so it looks like we got 3 choices here. I'm starting back in my mind. I'm thinking 3 decision variables. She wishes to obtain a new customer exposure level. Wishes, desires, like those are like constraints, of at least 50% within the city and 60% in the northwest suburbs. Each TV ad has new customer exposure level of 5% in the city and 3% in the suburbs. The dispatch ads have a corresponding exposure level per ad of 3.5% and 3% respectively. Well, the trade magazine has exposure levels per ad of 0.5% and 1% respectively. Okay, so it looks like things going into the calculation of how well we're doing with meeting exposure. Okay, so looks like that feeds into the constraints. The relevant costs. Ooh, costs. Now, I'm starting to think costs. I want to minimize those, right? The relevant costs are $1,000 per dispatch ad, $300 per trade magazine ad, and $2,000 per TV ad. The advertising policy is that no single media type should consume more than 45% of the total amount spent. Sounds like a constraint to me. Find the advertising strategy that will meet the store's objective at the minimum cost. Advertising strategy. What are we choosing? We're choosing between 3 advertising medium or media. So our decision variable is, let's make N the number of ads in the newspaper. Number ads in the newspaper. Let's make M the number of ads in the magazine. Number of ads in the magazine. And let's make T the number of ads on TV. Okay, there's my decision variable, right? That's my advertising strategy. How many ads in each one of these media do we use? My objective function, and I see that right in the last sentence there, I want to minimize cost. And when I say minimize, just like when we were maximizing profit, minimizing cost, now I have to determine how is cost, what drives cost. And see that it's $1,000 for each ad in the newspaper, times by the number of newspaper ads we run, gives us the total cost for the newspaper campaign. Add to that for magazine is $300 per magazine, times by M, total amount spent on magazine ads, and then $2,000 per TV ad, times by T, and I get total amount spent on the TV campaign. So combine all those, we get the cost. We want to minimize that. We do have constraints. Right? This is a trickier problem than what we've had before. So we're kind of kicking it up a notch a little bit. So we have, for lack of a better word, we have certain requirements to meet for exposure in the city. So I'll call it the city minimum. We have certain requirements in suburbia, sub-minimum, right? Suburban minimum. We have a certain amount that we can put in the newspaper, right? A certain maximum amount, right? 45% of total spending. We have a certain magazine amount, mag max, right? And we have a certain TV maximum, right? That 45, no individual, so no single media type should consume more than 45% of the total amount spent. That actually expands out into 3 constraints because each one of the media has this constraint. Okay. Kind of look, this is a tricky one here, and I try to see if there's anything else in there, but we kind of see that for the most part we're talking about customer exposure levels. Right, we have two requirements for that: 50% in the city, 60% in the suburbs. We have some sentences that describe the mathematical relationship. How do we determine those exposure levels? And we have the maximum amount to be spent on any single media constraint, and we don't see anything else. So now let's start to draw this out. So City Min, when we run a newspaper ad, we get 3.5% exposure level per ad, 3.5 times by the number in the newspaper. Now note, I didn't change this into a decimal. I could have changed it to the decimal. I could have done it all in decimals. It doesn't matter because we're not doing a calculation based on like finding a dollar amount of cost or anything like that, because we can, as long as we just leave the 50% exposure in the city as our requirement, if we leave that as 50, we don't have to change the 3.5 to 0.035. If we left it at 0.035, then the 50% exposure would also have to be 0.5. We'd have a lot more decimals, but really what we've done behind the scenes is taken those decimals, multiplied it by 100, and left it as percentages. And because we multiplied everything by 100, we haven't really changed the equation. Okay, and then 0.5% for the magazines, and then 5% for television ads. Ooh, nice increase in exposure there. Okay. Now there's a certain requirement, and so that's got to be greater than or equal to 50, right? So left it as all percentages. Same idea with the suburban minimum. 3n plus 1m plus 3t, and that has a target of 60% we want to achieve. Newspaper maximum, 1,000 times n represents the amount spent on newspaper, and that has to be less than or equal to 45% of the total expenditure. Now this becomes tricky because that's the total cost function, right? So I write that cost function in brackets, stretching it all the way out. Okay, a little bit complicated, maybe a little bit on the messier side, but essentially just 0.45 times by, how do I calculate cost? 1,000n plus 300m plus 2,000t. I roll with it the same way for magazines. 300m less than or equal to, again, how I determine that cost function again. And then 2,000 times t less than or equal to that cost function, 45% of that cost function again. Okay, so a little bit more verbose in the mathematics here, but it hasn't gotten tremendously complicated. Number of each one of these ads, we either run an ad or we don't, and we can't run negative ads, so they're greater than or equal to 0, and m and t are integers. And so there is our complete action plan right there. Now we're ready to roll into Excel, do some work here. Okay. So following the conventions we've followed so far, each column represents its own variable. And so we have newspaper ads, expand that column out a little bit. We have magazine ads, mag ads or magazine ads, whatever you like, and we have TV ads. We have the cost per ad, and those are just our coefficients. So $1,000 per ad for newspapers, $300 for each magazine, and $2,000 for each TV ad. We're deciding upon how many of these ads to run, so number. I don't know what those are. I'm going to highlight those in yellow, however. That is my answer. And then at the very end, we're going to find the cost. And this will be a function. And should we make cost? Make it peachy colored. Not that it's peachy, but different than money, which is green. Constraints. And I just listed them in words just like I was doing before. So city, min, suburb, min. We have a newspaper max. We have a magazine max, mag max. And we have a TV max. Entering the coefficients in my equations just like we normally do. 3.5, 0.5, and 5. And then we have how much we used. We have our limit. The limit is the amount that's actually we use in the equation. In this case, we want to hit at least 50. And it's going to be greater than or equal to that. So punch in the greater than symbol. Underline it. Center it up. And first constraint all done. Suburban minimum works about the same way. 3, just a little bit different coefficients. 1 and 3. We want to hit at least 60 there. And so we copy that greater than symbol down. The next 3 work a little bit differently. They still have their coefficients, newspaper. It's a less than or equal to, however. And on the limit has a calculation now, and that's 45%, so 0.45, multiplied, and then bracket. Now, I guess I don't really need this. 2 ways that I can do this. I can do the really complicated adding up, but I'm just going to reference, I'll get rid of the brackets, sorry, the cost, right? That R7 is the cost. Now, I have a newspaper max, I have a magazine max, and I have a TV max, and their maximums are all the same. So what I want to do is I want to punch the F4 key to put number signs around that R7, or where I'm referencing the cost, so that I can just pull that particular calculation down into the magazine row and then subsequently into the TV row. Okay. So that's something that's somewhat new. We haven't done quite that. We haven't done that before. Okay. Newspaper max 300. Magazine max 300 per ad, less than or equal to. That's good. And then same calculation, 45% of the total cost. Right. I just double click on that, make sure everything looks good. It does. Always concerned when I'm copying and moving formulas with cell references in them. If I miss a cell reference, it's really easy to make a silly mistake there. 2,000 per TV ad, and again, it's less than, and it's got to be less than 45% of the total amount spent. Whoops. Okay. Now I'm going to use my sum product calculation, use my sum product function, same way as I did before. Standard kind of equals to sum product, right? It's essentially what every cost function is, the sum product with the coefficients as one argument and the numbers as the other. So 1,000 times n, 300 times m, 200, 2,000 times t, those are each products, and then at the end we sum them all up. Right? It's exactly what sum product does. And my constraints calculated in a similar manner. Sum product, if I could type, that would be nice, sum product, close bracket, the coefficients, which I leave relative reference. That means no dollar signs in front of any of the rows numbers or any of the column letters. Because when I copy that down to suburban minimum, newspaper max, and so on, I want the coefficients to change because they changed. But I'm still looking at the same number of newspaper ads, magazine ads, and TV ads. That reference I don't want to change because they're the same for everybody. So I push the comma, highlight the numbers of each one of the ads, push the F4 key, push it right away, puts dollar signs around everything, columns and rows. Now that's absolute reference. No matter where I copy that particular sum product function, it'll always be referring as one of the arguments the number of newspaper ads, magazine ads, and TV ads, but it'll change the coefficient used in that particular calculation. Close the bracket and push enter. Now I can just simply copy this formula down and I'm all set, right? I double check, make sure it's referred. Now I know you see, hey, it's referring to this extra information, but as long as there's nothing in there, Excel sees that as zeros. So it just drops away. So not to be concerned that we're referencing cells that are empty. That's fine. Excel will just see those as zeros and we're good. We're no problems there. Still referencing the appropriate coefficient, still absolute referencing the number of each one of those ads. We're all good now. Okay. Now we're ready to run into Solver. So data, over to the right to Solver. My objective function, that's my cost calculation. Again, must be a sum product formula in there that we're referencing. Now this is important. This is easy to miss, and this is important. We're minimizing this cost, not maximizing them. So we need to switch that little button there to min. Very easy to miss. Where's our variables? Well, our variables are the number of each one of these types of ads to run. Okay, cool. Got constraints? Of course we got constraints. Click add, and I see that I have a bunch of constraints related to some maximums, some minimums, sorry. So I need to highlight, I can highlight those two because they're both of the same sign and they're both together. And then greater than or equal to each of their respective limits. But I have more. And I add. Now I see I have 3 maximums in a row, so I can highlight all 3 of those. The symbol, or the mathematical symbols less than or equal to. The constraint is I just highlight the 3. There are 3 associated or 3 respective cells. I know they have to be integers. This is the good place to add them. I click add one more time. And all that yellow stuff, the number of each of the types of ads, must be an integer. And I'm good now. Click OK. I see that I'm making unconstrained variables non-negative. Perfect. That's what I want. Change the solving method to simplex LP. Once I'm all satisfied there, I click solve. Solution comes up, no error messages. I'm very happy about that. I click OK. And so what does this tell me now? Right? It tells me I'm going to run 9 newspaper ads, 30 magazine ads, 1 television ad. It's going to cost me $20,000. I am going to have achieved an exposure level of 51.5% in the city, which is higher than my 50% requirement. So that's non-binding. However, my suburban minimum target of 60% exposure, what I got is 60% exposure. What my minimum requirement was the 60% exposure. That's a binding constraint. That's a limiting constraint on us. I spent $9,000 on newspaper ads. I was only allowed to spend $9,000 on newspaper ads. It's a binding constraint as well. I spent $9,000 on magazine ads. My maximum was to spend $9,000 on magazine ads. Again, another binding constraint. Newspaper ads, I spent $2,000. I was allowed to spend $9,000. I spent far less than the $9,000. Non-binding constraint. Essentially what that means is if this constraint weren't there, it wouldn't have affected the results. However, if we could spend a little bit more money on newspapers and magazines, we might have run more of those. But then it's debatable as to whether it would have enhanced our exposure levels. Don't know. That's one of those things where you sort of tweak it and experiment with it. But again, lots of information coming out of this result. Okay, awesome. Thank you.